Thank you so much, and thank you so much for hosting this. This is a really beautiful space. Hi everyone, my name is Elyse Kadokura and I am an epidemiologist with the Washington State Department of Health. And today I'm going to be presenting on how a project that I'm working on to use emergency department triage notes to detect non-fatal opioid overdoses. And I want to say the motivation for this talk for me was this is my first deep learning project, and I'm hoping that there's some NLP or deep learning experts in the audience who can give me advice on what I might be missing in my analysis and also directions that I can take next. So to characterize the problem, more than half of overdose deaths in the United States are from prescription or illicit opioids. But for every fatal overdose, there are many more non-fatal overdoses. And non-fatal overdoses are much harder to detect because you don't have death certificate data and you also don't have confirmatory lab testing. And people who have experienced a non-fatal overdose are much more likely to have a fatal overdose in the future, so it's of high public health importance to be able to detect non-fatal overdoses when and where they occur. So one of the primary methods that is used to detect non-fatal overdoses right now is a type of disease surveillance called syndromic surveillance. And the way that syndromic surveillance data is collected is when a patient walks into an emergency room and they're seen by a medical professional. The medical professional puts information about their visit into their electronic health record. The electronic health record sends data to the Department of Health, and public health practitioners who have appropriate credentials are able to query this data. So this is an example of what we might get for one particular visit. Admin day, demographics, chief complaint, which is a 2 or 3 word description of why the patient presents at the ER, diagnosis codes, and a triage note, which is usually written by a triage nurse, which is a more descriptive description of why the patient has presented at the ER. So traditional methods of querying syndromic surveillance data usually look for keyword terms in the chief complaint and diagnosis code. So if the word is present, it pulls the visit as a result for the query. If it's not, it doesn't. Triage notes has largely gone unexplored because it's free text, it's messy, it's noisy. People haven't really figured out how to use it, and the motivation for me to expose field is I think it's a rich form of data, and it's a shame that it should go unused. So here, there actually is an existing non-fatal opioid overdose query for syndromic data, and I put some of the terms up on this slide. This isn't all of them. These are just a few to give you a sense of what it looks like. So again, if the word is in the query, the visit will turn up in the results. If not, it won't. And I did a validation project using this query against a data set that I got from a hospital, where the hospital was doing an internal study on opioid overdoses. And they had collected a data set internally, and I used that as a gold standard. And I compared our query results against that data set, and the evaluation metrics that I used were precision, recall, and F1 score. Precision being out of all of the visits that were in the query result, how many of them were actually overdoses. Recall being out of all of the overdoses, how many of them were picked up by the query, and the F1 score is a combination of the two metrics. So the F1 score for our query was 0.66, which isn't terrible, but it's also not great. So the methods that I used for this project were I used active learning to build a training data set. I did some text pre-processing. The model that I used was a recurrent neural net, which is commonly used for series data, like text data. And I used gated recurrent unit cells to address the vanishing gradient problem. And I used Bayesian hyperparameter optimization to tune my model. So the hardest part about this project was getting a labeled training data set. Opioid overdoses are pretty rare. Less than 1% of ED visits are opioid overdoses. So I used a method called active learning where you start out with a small labeled data set and you train a model on that data set, and then you use that model to label a pool of unlabeled visits, and then you look at that newly labeled those newly labeled visits and find the ones that the model was the most confused about or the ones that they mislabeled, and then you relabel them correctly and put them in your training data set, and you do this iteratively. And the goal of this is to make a training data set that makes your model less confused, or to get a model that can more accurately label your training data set. And I use this in a way that's not as traditional. Like, I wasn't using this to get my entire labeled data set, but I was focusing on only picking up overdoses in my huge pool of data. So some more information about how I created my training data set. I pulled ED visits for an entire year, which was almost 2 million visits, and I used active learning to get 881 overdose visits, and this is by no means all of the overdose visits in this giant pool of data. It was just enough that I thought that I would be able to train my network using that. And I wanted my training data to have the same distribution as I would see in real life. So since overdoses are about 1% of ED visits, I had a 1:99 ratio of overdoses. I used a method to do hyperparameter tuning called Gaussian hyperparameter tuning, and it's different from doing a grid search or randomized hyperparameter tuning in that it uses results from previous runs to map your hyperparameters to this high-dimensional hyperparameter space where it chooses the next set of hyperparameters based on the values where you have the most potential to get a higher, on this y-axis is your evaluation metric, where you have the most potential to increase your evaluation metric. So in this example, even though this is an uncertain space, up here you have the highest potential of getting a better score. So it chooses these values for your hyperparameters as its next step, and in this way it's able to to find the optimal values for your hyperparameters faster than if you were to use a randomized approach. So using this method, I was able to find hyperparameters and get an F1 score of 29. So next steps, I want to test this model on real-time data for a short period of time and just see how it does. I also want to add additional inputs. I want to try to include diagnosis codes into complaint as inputs to my model to see if it improves. Not all visits have a triage note, so I want to be able to classify as many visits as possible. I want to do some additional text pre-processing. I said that I did some spell checking. Basically, I just spell checked words that were important in opioid overdoses or more common, like names of drugs and stuff, but I want to do more comprehensive spell checking in my corpus, but it's difficult because there are a lot of medical abbreviations, so I can't use a standard spell checker. I want to clean the training data set. I want to reclassify so that there were some mislabeled overdoses in my training data set. I would like to go back and clean my training data a little bit more. I would like to explore other neural net architectures like bidirectional RNNs, multi-layer RNNs, and I know that people are using convolutional neural nets for text classification as well. And my eventual goal is to create a mechanism, maybe an API or an app, where other epidemiologists could easily query the data using this model. If anybody has any advice about how to do this, because I have no idea, I would love to talk to you. And that is it. Are there any questions?
The question is, what architecture do you use?
Yeah, I used So I used a recurrent neural network with gated recurrent unit cells. So basically, a condensed version is that basically this is used for sequence data. So each of these is a time step. where in text data this would be considered like word 1, word 2, word 3, word 4. And then you use this as an input. It not only uses this as an input, but it also uses the previous hidden states to get your current hidden state. So that's why it's used for sequence data, because it uses, and it doesn't just use the data at that time step, it uses data from previous time steps to make a prediction. And I use scalar recurrent units because of the vanishing gradient. The Gator recurrent unit is a recurrent neural network, but it has additional features that where it learns what parts of previous hidden units to send to the next one. So in that way, you don't. I don't know if I'm going to text it. In that way, you don't have this vanishing gradient problem where hidden units from the beginning don't have as much effect on the final outcome. Does that make sense? I would be happy to talk about this more after. Yeah. Any questions?
What activation functions did you use?
The activation function I used a sigmoid.
Did you try NH or ReLU?
I used a sigmoid for my output layer. But this is more because I wanted it to be, in between 0 and 1.
Sure.
But I didn't use a tangent or
You mentioned that you trained the word to wake on your purpose. Am I right?
I'm sorry?
You trained the word to wake on your
Word to wake.
Did you do that in separate step and then build your model for prediction, or you combine?
I had an embedding layer in my model.
Oh.
Which I know that there are implications, like some people recommend to train them before you put them in the model, which I do want to try.
In sort of the ultimate use of the model, do you care more about precision or more about recall, sort of in how you're using it in a public health sense?
In a public health sense, we care more about. I always confuse in my head. We care more about recall, but I think, especially the query that we have currently, there are like a lot of false positives, which is a really big problem, because it's kind of like holistic resources to follow up with, a ton of false positives. But in general, we would rather have less false negatives. I feel like we might have one more.
Non-technical question. You mentioned in the end that you want to have some kind of API or app, so I didn't understand who you want your users to be.
Other epidemiologists who are studying, who are working on projects related to opioid overdoses.
Okay, but not for the healthcare, providers to actually identify those dark risks.
No, because to have access to our data, people who have access to our data generally work at local health jurisdictions. It's not usually people in hospitals. There's kind of a process to get access and get all the confidentiality agreements. So it would be people who already have access to the data are my people that I have in mind to be using it the most. Yeah. I think we're good.